Hi guys, this is Mrs. Tran-Bloom. How are you? Um, I'm actually recording this really early on a Sunday morning, so and my throat hurts a little bit. So currently I'm drinking some green tea and some honey. Okay. Anywho, okay. So what happened yesterday was I recorded this already, and when I listened to it on YouTube at about 8 minutes mark, my voice started to not align with my writing, so I'm recording it again. Hopefully, this time around, it has fixed itself. Okay. So example 3, find the inverse of each one-to-one function. State the domain and range of each inverse function. So what I'm going to do first is I'm just going to read you the direction, and then I'm going to zoom in to the mapping on example A. So example A, they gave you the input. The input is all the states. Okay, Indiana is mapped to 6.2 population in millions. This is your output. Washington is mapped to 6.1. South Dakota is mapped to 0.8. Somehow, South Dakota is not very populated. North Carolina is 8.3, and Tennessee is mapped to 5.8. Okay, so the first thing it says is to find the inverse. Now the direction says find the inverse of each one-to-one function. So these two examples, A and B, are already one-to-one, so you don't have to worry about checking to see if it's one-to-one. Okay, so we're going to find the inverse first, so hopefully you can see what I'm writing. Inverse. Okay, that means I'm going to write it in a mapping format. Okay, however whatever format they gave you initially, that's the same format we're going to use to write its answer. So the inverse, our input is now the output, so it's going to be the population in millions again. Okay, so that's an I. There you go. And so I'm going to zoom out a little bit now that we know the numbers. Okay, so we're going to draw, instead of a square, I'm just going to draw a circle here. Then my output is going to be the states. Okay, and another bubble. Okay, so population in millions. 6.2 is mapped to Indiana, and I'm just going to use abbreviation. 6.1 is mapped to, you do need the arrows here in the end to represent that what is mapping to, is mapped to Washington. 0.8 is mapped to South Dakota. And 8.3 is now mapped to North Carolina. And 5.3, no, I'm sorry, that was 5.8, mapped to Tennessee. Okay, so this is my output in a mapping format. In addition to, not the output, the inverse. This is the inverse in mapping format. In addition to finding the inverse, it said, hey, go and state the domain of the inverse. Domain and range. So the domain and range. Okay, domain and range are the set notation. So you need these wavy lines here. So the domain is currently the input. So we're going to write it in order. So 0.8 is the smallest number here. And the next one is 5.8. The next one is 6.1. The next one is 6.2. And the last element in our domain is 8.3. Your range is going to be all the states. I'm just going to write them in order from top to bottom. Indiana, Washington, South Dakota, North Carolina, and Tennessee. So those are the elements in domain and range. So I'm going to box that up because it did ask for those. Okay, and then in addition to it also asked for the inverse. All right, for B. For B, it gave you the function in a set of order pairs. So we're going to find its inverse. And when you guys are writing notes, okay, be neat, be clear. So that way when you need, when you're struggling with your homework, you can go back to your notes and know exactly where they are. How to find it, okay? When I stamp your notes, some of you are just so messy, I can't even see what you're writing. So I can't imagine your notes. It's very helpful to you. So just try to be neat. Inverse function is going to be a set of all the ordered pairs. So now I'm just going to switch my x and my y. So 1 comma negative 5, 3 comma 3, 0 0. You can't really switch them because they're identical. Okay. Then we have negative 4 comma 2. Then the last piece is going to be negative 8 comma 7. Right. So in addition to finding its inverse, it's asking you to find the range and domain of its inverse. So what I would like for you to do right now is go ahead and list all the elements for the domain and list all the elements in the range. Okay. So these two you guys are doing on your own, and I would check them when I'm sampling your notes in class. Now if I'm going too fast, please just hit pause, okay, and then finish writing and then go on to the next example. Example 4. Verify that the functions are inverses of each other by showing that f of g of x equals x and g of f of x equals x. Give any values of x that need to be excluded from the domain of f and domain of g. So here's, let me zoom in really quickly. Alright, so it says that before you verify, tell the exclusion or find the exclusion of the domain. So g of x equals x to the third. Okay, this is a function that looks like a lazy s. F of x equals third root of x. So this is a sideways lazy s. So right now, we don't have to exclude anything from these two functions because they're both 1 and 1. Okay, so to show that they're inverse of each other, we're going to break this into two columns here. On the left, we're going to show f of g of x to see it comes out to be x. Now, the word is and, so it's super important, okay? They both have to come out to be x for these two functions to be inverses of each other. So g of f of x equals to x. Anytime that your direction or your instruction is to show that or prove this, you have to be super neat, and you have to write out every single thing that you do. Even though things that might seem very easy or stupid, you still have to write it out. Alright? So here we go. G of x, this is my new input, and g of x is this piece right here, which is x to the third. So my first step is to substitute g of x for x to the third. Okay, and on the right hand side, I do want you to carry down x every time. So now I just have to look at f. Okay, so this is telling me that f is now going to have a function of x to the third every time I see an x. So my input is now x to the third. So here's my f function. It started out as a third root of x, but my new input is no longer x. My new input is x to the third. That comes out to be x. Okay, x to the third is 3x, and then you have a third root, so that means we can pull out one. So now we have x equals to x. So on the left hand side, we do know that f of g of x does come out to be x. Now on the right hand side, I wonder if that's the case as well. So here we go. G of f of x is the third root. Is the third root of x. Okay, bring down your x on the right. Then I'm now going to focus on my g function. Okay, g function said, hey, there's an x to the third right here. So I'm going to go, hey, parenthesis to the third equals x. My input is third root of x. Okay. So now how we know on the left it cancel out. Now how would the right cancel out? Okay, so this means I have 3 of these. So let's just write it out 3 times. So we know anything that you see the power to the third means I got 3 of those. Well, when you multiply, okay, radical with the same index, you can put it all under 1 as well. So now, because they all have index of 3, we can totally just put them under 1 radical. So we have 3 x's with the index of 3. We can pull one out. So therefore, on the right also comes out to be x. Now we did the work, okay? We did the mathematics. Now we have to write the solution, okay? So therefore, because we prove f of g of x is x and g of f of x is x, therefore f and g are inverses of each other. And this is actually also part of the solution. Okay, so you have to circle a box out and then all of these steps neatly written out. Now, doing the composition is one way to prove two functions are inverses of each other. Another way is also graphical. Okay, so in the later example, we're going to show how we can also graph it out to prove that the two functions are inverses of each other. Alright, so what I'm going to do right now is I'm going to skip B and I'm going to go to C. Okay, so go ahead and follow along. If you're not quite done, go to hit pause, finish writing, and then go to C. Alright, so C is asking for the same exact thing. Okay, it's asking for us to prove f of g of x, does it come out to be x, and okay, and it's important, both have to be true, g of f of x, does it also come out to be x? So here we go. So I'm going to write f of, okay, my g function is 3 over x minus 5. So 3 over x minus 5. Does it come out to be x? Then now it's telling me that f of this input, okay, so I'm going to focus on f only. F is 3 divided by x, so 3 divided by x. I'm going to substitute x with my new input. And then whatever the new input is, I'm going to add it to 5. Okay, so this is the stuff right here. So notice how this x right here, I'm kind of leaving it blank so I can fill in this input. So that's 3 over x minus 5. Okay, so does it come out to be x? So right away, you can see that the negative 5 and the positive 5 will cancel out. So now you have 3 divided by 3 over x. I'm going to write the division symbol using my 2 dots. So 3 over x this way. Okay. So now if you look at this, I'm going to make my 3 into a fraction. So I'm going to put 1 underneath. My next step, since I'm out of space, I'm just going to go up here. Okay. When you are dividing, we're going to multiply by its reciprocal. So 3 over 1 times x over 3. Questionable. Does it come out to be x? Now, 3 over x, we can reduce, right? So now we just have x over 1, which is simply x. X does come out to be x. So on the left, it does come out to be x when we do the composition. Now on the right, let's check out to see if this is also true. We're going to do g of, okay, equals x. F of x is where my new input's going to be. So f of x is 3 over x plus 5. So 3 over x plus 5. Then now I'm just going to focus on my g function. My g function says 3 divided by x. So 3 divided by a blank space. And then I'm going to carry down my minus 5. So minus 5. And this time the minus 5 is on the side. Okay. So now I'm just going to put my new input in. So 3 over x plus 5. This is 3 divided by 3 over x plus 5. So technically I'm going to write it using my 2 dots. So 3 divided by 3 over x plus 5. Okay. And then bring down this minus 5 equals to x. Now, similarly to the left, I'm going to make my 3 into a fraction by writing a 1. So when you have multiplication, when you have division and subtraction all in the same line, you're going to do multiplication first, okay? So when you're dividing, you're going to multiply by its reciprocal. So I'm just going to write this over here, okay, since I'm out of space. So I'm going to write 3 over 1 times x plus 5 over x minus 5. And that, I'm still out of space, does that equal to x? Okay, so now, what I have is So now what I have is 3 times quantity of x plus 5 all over x minus 5. So let's see what this is going to come out to be. Okay, I feel like something's wrong. Let me see if I wrote the question right. So f of x is 3 over x plus 5, so we did that correctly. Then we're going to focus on the g function, so 3 over x, so it's now 3 divided by 3 over x plus 5, so that's correct. And then minus 5, I wrote it as 2 dots, so 3 over 1 divided by using 2 dots. So we haven't done any math here at all. 3 over x plus 5, and then bring down my minus 5. When I multiply, when I divide, I'm going to multiply by its reciprocal. So currently, this is what I have. Okay, so this is going to come out to be 3 over, so now I'm just going to multiply across. Okay, so in a problem when you have multiplication and division, multiplication and subtraction all in one, we can just do multiplication first. Okay, so the next step, let's see. Let me see if I want to write that down. Oh, this is the thing right here. You know what? That's why I was kind of confused. When I take this reciprocal, it's supposed to be x plus 5, so that's on the numerator, over 3, not over x. Okay, there you go. So we can do this 2 ways. We can multiply across, okay, or we can reduce the 3. So there you go. So if I reduce the 3, and you can multiply across and then reduce later. So now I have an x plus 5 minus 5 equals x. Okay, just bring this negative 5 down. A positive 5 and a negative 5, those two will cancel themselves. So I do end up with x come out to be x. So they're both proved to come out to be x. So we're going to write, therefore, f and g are inverses. Okay. All right. So now that you've seen 2 of them, okay, what I would like for you to do is to go back, and I would like for you to do example B. Okay, earlier I said we're going to skip it, and this is where you're going to come back and do this on your own. So I would like for you to do this on your own. Okay. So now that you've seen 2 examples, do this on your own. If you don't understand it or still struggling, then just listen to the tape again. And then so when I send you notes, I expect you to have this all completed. Okay, so our last example of this video is the graphical. So example 5. The graph of 1-to-1 function is given to us. Draw the graph of its inverse. So for this particular one, it gave you 3 points, okay, 3 nice points. It's already labeled for us. So to find its inverse, just like the previous example, we're going to switch x and y. So to switch x and y, this is now negative 2 comma negative 1. So to switch x and y, it's going to be negative 1 comma negative 2. So here's negative 1, negative 2 is this point. Every point that you use, label it. Okay. This point is negative 1 comma 0. To find its inverse, I'm going to switch x and y, so 0 comma negative 1. So here's 0 comma negative 1. Label it. The next one is going to switch. This is 2 comma 1. We're going to switch it by using 1 comma 2. So here's 1. 2 is all the way up here. So label it 1 comma 2. This doesn't go on any further, so we're not going to use arrows. Okay, and we're going to label this f inverse of x. Okay, so the notation is super important. Anytime you have multiple graphs on one coordinate plane, label them. All right. So your next task, okay, is to do B. Oops. Okay, is to do B all on your own. If you look at this one, you have arrows on the 2 ends. So make sure you have arrows on your inverse. And if you look at this, you have 1 dot, 2 dots, 3 dots, 4 dots, and 5 dots. So when you find its inverse, I also expect you to have 5 dots, okay? It's not labeled nicely for you, but that doesn't mean you can't find the points on your own. So find the points of the original, switch your x and the y, and then plot your inverse that way. Now, once you're done, okay, anytime you're graphing and once you're done, I would like for you to ask yourself, okay, do those two functions, okay, the function that you graph, does it look like it's symmetrical about the identity line? So this is called the identity line of y equals x. So what that means is, if I were to fold it along this line, the identity line y equals x, it's the top and the bottom, okay? Are they going to line up perfectly? If you said yes, then you know you have graphed correctly. If you said no, then you need to go back and fix it. And that's just a really quick way of checking your solution. All right? Okay, this is the end of my notes. Excuse me. So I'm just gonna try to see if I can give you a joke, right? All right. What joke should I give you today? Okay. What do whales like to eat with peanut butter? So the joke is, what do whales like to eat with peanut butter? Jellyfish. Ha ha ha. Get it? Jelly. But it's fish. Jellyfish. All right. Have a good day, and I'll see you guys next time.